Okay, for what we have in the case of question number 6, now we have an exponential equation whereupon we have 125 is equal to 25 raised to the negative x plus 5. And this is an equation that will have a common base. That is a common number that will multiply itself into both 25 and 125, and that number is going to be at 5. Now, for 125, if I re-express in terms of the exponential base 5, 125 is going to be 5 to the third. For 25 to the negative x plus 5, again, we have 25 is 5 squared. 25 to the negative x plus 5, we have 5 squared. Quantity to the negative x plus 5. Now we have, to the left, we have 5 cubed. And to the right, we have with the power property of exponents. So a base to a power to another power is going to be the same base raised to the product of the powers. So we have 5 cubed is equal to 5 raised to the negative 2x plus 10. And now that we have single base 5 terms on each side, we can set the powers equal to each other. So we have that 3 is equal to negative 2x plus 10. And isolating the x term, if I take 10 away from both sides, we have 3 minus 10 becomes negative 7. Negative 7 is equal to negative 2x. And we have, with division by negative 2 on both sides, okay, we have negative 2x over negative 2 is x. Negative 7 divided by negative 2 is where we have a negative over a negative to be a positive. So we have x to be exactly 7/2 or 3.5. For what we have in the case of number 7, now we have in this one, we're looking at solving for x, whereupon we have e raised to the 3x is equal to 4. And to take care of the e, we'll be taking the natural logarithm of both sides. So you have a base e logarithm of e to the 3x is equal to the base e logarithm of 4. Base e logarithm of e to the 3x, that goes to 3x. And we have 3x is equal to the base e logarithm of 4. And again, we have base e logarithm of 4 is going to be the natural logarithm of 4. And if I divide out by 3, okay, so x is equal to 1/3 of the natural logarithm of 4. And if I approximate to the nearest hundredth, so we have with 1/3 of the natural logarithm of 4, okay, x we have at 0.46. Now, in the case of what we have for number 8, okay, and we have a word problem here. It says, suppose that the number of bacteria in a certain population increases according to a continuous exponential growth model. Here we have a sample of 2,400 bacteria selected from a population that has reached the size of 2,717 bacteria in 2.5 hours. And it says to find the hourly growth rate parameter. And it says to write your answer as a percentage and to round the percentage to the nearest hundredth while not rounding to any intermediate computations. All right, so we can take, you can use several different variables for the exponential growth model. And we'll just say we have a is equal to p times e. to the r times t. Now for the values, okay, we have future value A, okay, we're looking at 2017. P is the starting value, which was at 2400. And for what we had for the time span, okay, that was for 2.5 hours. And looking at taking what we have in this equation. So we have A, again, we have at 2717. P we have at 2400. We have times e to the r times t, and we're looking at solving for r, and t we have at 2.5. And we have next stage, if we look at division, say 2717 over 2400, and we have is equal to e raised to the 2.5r. And in taking what we have now to get rid of the e and just have the right hand side expressed in terms of just 2.5r, I can take the natural logarithm on both sides. And we have with the numbers. So for 2717 over 2400, now I'm not rounding, but just among the first digits on display at 0.12405, and we have is equal to 2.5r. And for the natural logarithm of 2717 over 2400, and we have dividing by 2.5, and we have for your value r, among the first digits on display, we have 0.0496238, and writing as a percentage and rounding to the nearest hundred. Okay, so going from decimal to percent, so I'm looking at moving 2 places over. And for the rate, okay, we have 4 point, okay, and to the nearest 2 decimal places within the percent, we have 9, 6, and the 2 indicates that we're going to round down to where the rate is going to be at 4.96%. And that's going to be your percentage regarding the rate of growth.